All right, everybody. So here's where we left off in lesson number 2. So I know we didn't finish. If I'm remembering correctly, we finished g of x in the notes that I posted, but I asked you to try j of x kind of like for homework, and I said we would go over it next time we're in school. So since this is next time, let's go over j of x. So again, the basic idea here, especially for those of you maybe that weren't even in class when we started this lesson, bless me. Is you have to go through and switch the x and y value when determining an inverse. So that's what we're asked to do here. So to determine an inverse, we're going to switch the x and y. This technically is kind of like a y value. So because that is kind of like a y value, when I switch x and y, I'm going to get this equation. So all I'm doing is I'm rewriting the equation, just instead of x and y being where they are, I'm just switching them. Now we just have to use our algebra skills and what we know about exponents to get y back by itself. So I'm going to start by subtracting by 8. So I have x minus 8 is equal to 1/4 x to the 5/3. To get rid of 1/4, I want to multiply both sides by 4, because if I multiply 1/4 times 4, it's going to give me 1, opposite operations. So I'm going to be left with 4x minus 8 is equal to x to the 5/3. Now to get 5/3 away there, I want to raise that exponent to an exponent that it's reciprocal, because if I have a reciprocal there, when I multiply a fraction by its reciprocal, they cancel and just become 1. These are y's actually. So when we have this, we're finished by solving for y. So we have y is equal to 4x minus 8, all to the 3/5 power. To leave it just like that, since it's a function, we can say the inverse function, j negative 1 of x, is equal to 4x minus 8, all to the 3/5. We can even use our rule of exponent over root to say that this is the same thing as the 5th root of 4x minus 8 to the 3rd power. All of these things are the same exact expression. We're just showing that they are all different or written differently. Okay. So moving right along with the lesson, right? We have to be able to find inverses of these kind of interesting functions as well. These are known as rational functions. The graphs of these are kind of really weird looking. You'll find out a lot more about them when you're in pre-calculus. And there's an interesting thing that happen here when you're trying to find the inverse. So just like all of the other inverse questions, when trying to find the inverse here, you want to switch the x and y value. And let me make my pen a little bit thinner here because these tend to have a little bit more work. So if I switch the x and the y, I'm going to put x over here, and I'm going to have a y plus 1 and a y minus 4. And now I have a problem. My problem is I have two y's, and I'm asked to solve for y. To be able to solve for y with two of them, I'm going to have to do a little bit of math magic, right? We're going to try and get the y's together and do something here that allows us to get the y's to be just one of them. So the first thing we want to do is put x over 1 and cross multiply. If I multiply anything times 1, it's itself. So I have y plus 1 times 1 is just y plus 1. If I multiply x times y minus 4, I'm going to get xy minus 4x. I'm going to use the distributive property there to do that. So still I have a problem. I have two y's and I want to solve for just one y. So I'm going to move my y's so that they're together. So I'm going to subtract this xy to the other side. That's going to leave me with y minus xy plus 1 equals negative 4x. And then I'm going to move the 1 because it doesn't have a y, essentially trying to get one side of the equations to just have the y's. And then here's my little math magic trick, which you already know. It's called Gcf Factoring. So if you look here, I have a y and I have an xy. The common factor is y. So if I take y out, or divide y out, I'm left with 1 minus x. And then I could divide away the 1 minus x so that my y is by itself. That's my goal, right? Find an inverse means switch x and y and then get y back by itself. So we've done that. So we can say y is equal to negative 4x minus 1 divided by 1 minus x. Since it's a function, we'll use function notation and say negative 4x minus 1 over 1 minus x, and we are done. We know that the inverse is going to be a function because this original function f of x is 1 to 1. How do I know that? I graphed it and I saw that it passes the horizontal line test. So let's take a look at h of x. We're going to do the same thing for h of x. So if we switch x and y, I have x equals y plus 5 divided by 6 minus 2y. Again, we're going to do the same thing, put x over 1 and do some cross multiplication. So I'm going to get y plus 5 is equal to 6x minus 2xy. Just like we did above, I want to get it so that the y's are together. So I'm going to add 2xy to both sides. That's going to cancel here. And I'm going to leave myself with y plus 2xy plus 5 equals 6x. But I don't want that 5 there. I'm going to move it to the other side. So I have y plus 2xy equals 6x minus 5. If I then divide out the y's like I normally would do, I'm going to get 1 plus 2x equals 6x minus 5. Divide both sides by 1 plus 2x. And we get our final answer, which is y equals 6x minus 5 divided by 1 plus 2x. Since it's function, we can say function notation 2 here. I'm running out of space, but I'll fit it. And this is 1 plus 2x. There you go. If we were doing this lesson in class, I'd even say, all right, try the next one by yourself and then compare your answer with your partner. So if you want to try the next one by yourself, just pause the video, give it a couple seconds, try it, and then replay it and see if you got it right? Kind of self-check here and see if you know what you're doing or not. So if you've paused and you've come back, that's great. And now we can kind of see, all right, did we do this right? So the first step I'm hoping that you took was you switched x and y. That's, I'm hoping at this point, the obvious step. You then cross multiplied and get y plus 1 equals xy minus x. You then move the xy to the other side, and we'll do this in one step since you tried this one on your own, and move the x to the other side. So you left yourself with y minus xy equals negative x minus 1. You did your magic trick and got it so that the y was by itself. And then you divided by 1 minus x. And you got your final answer, h negative 1 of x is equal to negative x minus 1 over 1 minus x. And this would be the time of the lesson where I'd have hands go up and they'd all be saying, Mr. Servino, I think I did it right, but I got a different answer than you. And that's because this fraction can be shown in 2 different ways. So in the denominator, you see how it's positive 1 and negative x. Well, if I multiply that by negative 1, I'm going to get a completely different looking answer. It's going to become x plus 1 over x minus 1. Right, notice I'm multiplying the same thing in top and bottom, so we're winding up getting a different answer here completely. It's actually equivalent. So if you got this answer, all you did was when you cross multiplied, you just solved in a different way. So you move the y over instead of moving the xy over. It's actually going to give you the same exact answer. So if you got a different answer here, it's okay. This is another possible answer that you could have gotten. So what I'm saying here is this is a good answer, and so is this one. They're the same. All right, hopefully this lesson video helped you, and we'll keep going here because there are a couple things that we have to talk about with inverses. Okay, so before you move on to the homework lesson, let's move on to 5. right? So we've moved on now. So we talked about inverses. We talked about how to find these inverses. So hopefully this video is helping. But now we have to talk about kind of like the tricky things that happen with inverses, like number 5. Number 5 gives you the inverse. That's what this notation means. And it wants us to find the original function. Well, if I know the inverse, we have to then think, well, what could I do to an inverse to find back the original function? Well, the inverse of an inverse is the original function. So even though this is asking the question differently, it's really just asking us to continue to do the same thing. Find an inverse here. We then would subtract 3. So we'd have x minus 3 is equal to y minus 1 to the 3rd power. We then can take the cube root of both sides, right? Because when I cube root something cubed, it cancels. And then we can move the 1 to the other side. So then we'd be able to say y is equal to 1 plus the cube root of x minus 3. If you put the 1 in the back, it's not wrong. I like just putting it in the front. And then since we know that this is the original function, it's the inverse of an inverse, we get our answer here, and we are good to go. Number 6 says, does f of x equal x squared minus 6 have an inverse? All right. Everything has an inverse, but we're asking here, does it have an inverse function? Because remember, we care about things that are functions. So the graph of x squared minus 6 is a parabola. It's going to fail the horizontal line test, right? Meaning it does not have unique y values, right? So the x values are all different, but the y values, some of them are shared. For example, these 2 points would have the same exact y value. That's what failing the horizontal line test tells us. So this function, f of x, has no inverse function, right? The inverse of this is going to fail the vertical line test, essentially, is what the horizontal line test tells you, right? The reason why we know this, right, is because f of x is not 1, 2, 1. Okay. Next, says our main goal of this unit is to find the inverse of exponential functions. So the main goal here, so we have this new function that we're going to start talking about in lesson 3 called a logarithm. What's so special about a logarithm? Well, it's the inverse of an exponential function. So because of that, we have to talk about exponential functions again. So it says, why must every exponential function have an inverse? No matter how you graph an exponential function, and I'm going to show you a couple here, okay? So if I graph like a basic function like 2 to the x, it's going to look like this. If I graph a basic function like 1/2 to the x, it's going to look like this. If I graph kind of like a crazy function with like a vertical shift, right? We have all these different functions. It doesn't matter what type of exponential function you have. They're all going to be 1-to-1. So we can say here, just basically to sum things up, is all exponential functions are 1-to-1. Because they're all 1-to-1, we know that they all have inverses that are functions. So we could say, so all have inverse functions. So we should just be able to switch x and y. So if I say x equals 2 to the y, I can now find the inverse. Now I know kind of what's going on here, right? So if we don't know what's going on here, well, we can't get y by itself. That's our problem. That's our big problem right now. So because of that, we have to come up with something new to do. And that's what lesson 3 is going to show us. Hopefully this lesson was very helpful for you. Make sure you watch the homework video that'll be attached in the same Google Classroom post here, and we will be good to go. All right, good luck, and I'll talk to you all very soon.